Testing, testing. All right. Hello?
Hello.
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 Thanks for coming. We're just waiting for some more people to show up.
Okay. Notice that.
There we go. So we're just gonna wait like a couple minutes for more people to show up because I kind of sent the link late. Um, but can everybody hear me fine?
Yeah, I hear you fine.
Okay. I think I'll start at 7:07. All right. So, hi guys. My name is Steven. Some of you already probably knew that. And so this is today's webinar on ArrayLists and for each loops. Unfortunately, Asta and Hannah couldn't make it today because they had conflicts or were like extremely busy. So I guess I'll be the only tutor for this webinar. So if you have any questions, just feel free to ask. But I wanted to start off by asking you guys how much you know about ArrayLists and for each loops, if anything. So I can kind of like gauge like what kind of background you have. So you can just type in the chat, or you can just like unmute your mic and like tell me, what you know about ArrayLists or for each loops. Hello? No. Okay. And if you guys are typing in the chat, could you please type in the group chat for the Google Hangout? Okay. So from what I'm reading, it's kind of like you guys like are sort of comfortable with it. Wait. No. Devon, you're talking in the wrong. Seeing your comments in the call. Yeah. Okay. So, from what I'm reading, you guys kind of have like, a semi understanding of it. And that's fine. That's perfectly fine. I'm gonna be going over it as in depth as I can. I can see you now. You're typing in the right chat. So, I'm just gonna like kind of go over ArrayLists in general. They're gonna be really the only. Well, yeah, I think like one of the only list classes that you'll need to know for the AP exam. And they're really useful and they're really helpful if you know how to use them right. First, what I'm going to do is I'm going to share my screen and we're going to go through the ArrayList, the ebook. So can you all see my screen? Okay. All right. So with the ArrayList class, well, it's basically an ArrayList is, well, first of all, it's a list, but it's a list that kind of takes the form of an array. It's very similar to an array. And when I say that it's a list is kind of just like, well, you would think a list. It's like it's a collection of objects that have some order. So you can think of like lists as like you have like a list of items or like a to-do list or like a list of, your top 5 favorite celebrities. Like there's some order to a list, and that's kind of like the same thing where you have like a collection of items that have like some order to them. So like there's a first element, a second element, a third element, fourth element, and so on. And an array list is basically So an array list is basically just a list that takes the form of an array. So you can think of it as being an array, but like each element corresponds to like a different element in the list. So like you'd think of like the elements, the first element being the first element of the list, second element, and so on. So there are a lot of ways to implement the list interface. And basically, that's just what an array list does, is it implements the list interface. Have you guys learned about interfaces yet? So that's going to be for another webinar. We'll talk about that later. But just know that array lists implement the list interface, and what that basically means is that they have access to methods that are in the list interface. And I'll explain more of that in a later webinar, but just know that implements the list interface. And there are other classes that implement the list interface, like linked list, stack, etc. But you probably don't need to know these three for the AP exam. All right, so let's just look at an example. Syntax of how to create an array list. So in this example, you have this public class called test, and you have this main method, and you have the statement that creates a list, and you can see that's just of type list called name list, and it declares a new array list. Now, since we haven't really gone over polymorphism, this can kind of seem confusing because you may not be used to seeing different. So like you have like a list, but you're declaring a new array list. So I'll simplify this to where I just have it say array list. And you can just have array list name list equals new array list. Just kind of like how you instantiate any other object in Java. And there are like three key methods that you need to know with array lists, and that is get. And I'm just looking at the Java 8 API. That's get, and it basically returns the element at the specified position in the list. So just to say like name list get, and then I passed in, let's say like 0. It's kind of the same thing as if nameless, let's say we had an array. There's 100 spots in the array. It kind of be the same thing as saying like names and then brackets 0, and then doing something with that value. You're saying like string Johnny equals names or something like that. So basically, the get method of an array list can kind of be seen as the same thing as accessing the index or accessing the element at the given index in an array. And so that's the get method. You also have the set method, which basically replaces the element at the specified position in the list with the specified element. So basically what that means is that you're just setting the element at the index that you want with this element E specified here. So let's see. Let's to set, let's say, I guess I'll just go with the Johnny example. If I was to set like element at index 0 to Johnny, and when I run this code, it would basically, and I wanted to print out Johnny, or print out nameless.get at 0. This would print out Johnny because I'm setting the element at index 0 to Johnny, and then when I call get, it basically accesses the element at 0. The element at 0 would be Johnny, and print out Johnny. All right, and then lastly, we have add. This is kind of like where an array list is very useful and why we sometimes refer to over an array. I don't know if you guys remember, but like when you have an array, it's really hard to like add elements like in between two indices because you know what you'd have to do is you'd have to copy all the elements in the array, and then you'd have to insert the element, and then you have to copy like the rest of the elements, and like you'd have to change the size and everything, and you know it could kind of just get messy. But with array lists, um, the size of the array like automatically changes for you. So you can just call this method called .add, and then you could add like anything that you want. So like you could add Johnny, and basically what it's going to do is it adds Johnny to the next available spot in the array. So in this case, sorry, in indice, adds it to the next available index, and if you keep calling add, then it'll literally just add it to the next available one. So like if you Steven and then you call get at 0, get at 0, it would return Johnny. And the reason why is because Johnny was the first element that we added. But if you called get at 1, then it would return Steven because that was the second element that we added. And so you can see it kind of just like it adds, you know, to the next available spot in the array list. So those are like the three main methods that you need to know about array lists are get, add, and set. Are there any questions? All right. So if we run this code, and we print out this array list, it'll basically say Diego, Grace, and Deja. And it kind of like what positions they are in the array list. So like this would be the first element, this would be the third element. So yeah, let's see, create some virtual list of objects. So in this one, in this example, you can basically you can have an array list that holds not just like string objects, but like you know really any type of objects. So like in this case, they're adding integer objects are basically kind of like ints, but you know they provide some other functionality. And so if I ran this code here, what do you think would happen? So I add a new integer 1, add new integer 2, set 1 new integer 3, and then add 1 new integer 4. Then I add, and then I print out the list. And whenever you print out a list, it'll print out the order. So what do you think would happen? Like, what do you think? Tell me what you think the order of the elements would be after I ran this code. I'm just gonna have to like periodically look at the chat because oh, type your responses in the group chat. If you can see where Davon and Steven are typing their responses, type them over there. Okay. See, 1, 2, 2, 3, 4, 5. It's a set of repeater. Okay. Let's see. All right, I'll give you like another minute, and then I'll run this code, and we'll actually see what happens, see what the output is. And if you're confused, then I'll step through it, and we can see why the output is the way it is. Actually, I could put this through Java Visualizer, and we can kind of see what happens together. All right. So 1, 2, 1, 3, 1, 4, 5. All right. So let's run this. And our output is 1, 4, 3, and 5. Now, we look at why this is. Let me go to Java Visualizer. Make sure we don't need this. Actually, yeah, actually, I think we do need this. Okay, there we go. All right, so I know that it still says list, but I don't know, just disregard that syntax for now. So if we start at here, declares an empty array list, or sorry, an array list. This arts is taking in an empty array. I don't know why they have arts there, but so we add a new integer called 1. Actually, it looks like they don't support visualizing array lists, and they only support arrays, which is kind of unfortunate, but I guess I'll walk through it myself. So when you declare this array list and then you add a new integer 1, then the elements at the first index in this array list will be 1. And then when you add 2 to this array list, then the element at the second index will be 2. But when we call set, it's basically, remember that this is the index that you want to set the elements at, and this is the actual element that you want to set at that index. So if we wanted to set this at index 1, and remember that Java has zero-based indexing, so this would actually be referring to the second element, then we'd set we'd set the element 3 at the second index in the list, number 1. And so we'd have 1, and then it'd be 3. And then we have list 1.add 1 new integer 4. And what that do is it would add it to oh yeah, when you call add, also forgot this. Yeah, but when you call add and you pass in when you call add and you pass in an index and an element, it's kind of the same thing as set. You insert the specified element at the specified position in the list, and it shifts the element that's currently at the position, if there is any, elements to the right. So it's basically like you're inserting it and you're pushing everything that's to the right of it forward. It's kind of like you're squeezing it in there, and like everything else gets pushed back. So in this case, when we add 1 to this list, or we add 4 to this list, and we set it at the index 1, we're basically inserting 4. We're squeezing it in there at index 1, and everything else gets pushed back. So in this case, 3 would get pushed back, and then 4 would be at the second index, and then you add a new integer 5. And since this is just like the normal add function, it would basically just go to the next available spot in the array list, which would be the that'd be the fourth position. So yeah, once we print it out, then we get this input or this output. So you have 1, 4, 3, and 5, and yeah, that pretty much just follows how our code went and how our method calls went. So do you guys have any questions about that? It's kind of hard to explain it when I couldn't have the visualizer to actually like show you where the items were. But I don't know, hopefully that makes sense. Why didn't the 3 get replaced with 4 again? Oh, okay. So yeah, so basically when you call add and you pass in an index and you pass in an element, so in this case it's the integer 4, what happens is that it squeezes the element. Well, I guess it's not really the best thing to say. It inserts the elements at that particular index, so at index 1, but it also shifts any elements that are at the current index, and all those elements that are from the current index to the end of the list, it shifts them to the right, so you have an open space now. Think of it like I had sorry, words being slow. Yeah, but just think of it as I had 1, and then it was 4, I think. No, it was 1, 2, and then 4. And basically what we did is sorry. I just need to make sure that I get the numbers right. So it was 1, and then it was 2, and then you set 3 at 1. So it was 1, 3. Okay. So it was 1, 3. And then we called add, and we pass in the index as 1, and we pass in the element as 4. Does is it squeezes in here. It goes right between the 1 and the 3. So what add does is at this index, but if there's already an element at the index, then it shifts it to the right. So it shifts it to the end of the list. So in this case, you'd have 1, 4, and then 3. And then the last call was you just add 5, and it just adds it to the next available position in the list. So that'd be at position 4, or the 4th position. And then this is your final output. Okay. All right, nice. So any questions about that? And you guys can unmute your mic. You don't have to always have it muted. Just make sure that if you unmute your mic that you don't have someone else talking at the same time. All right. So to check your understanding, this is kind of like the example that we did. So what will it print when the following code executes? You have this list, and this is generics, but I don't know, just disregard it for now. Just know that when you have generics and you pass in an object, that it basically says, okay, I have to have a list of integers. And this is basically what it's just saying. I have a list of integers, which actually points to an array list of integers. And then we add all these integers, we set an integer, we add another integer, and then we print out the list. This is using the same methods that we've looked at before. So can you guys tell me what the code will execute, or what list one will print out once it's done? I want you to be very careful and make sure that you understand the difference between set and add when you have two arguments. Okay, C. All right, for the sake of time, I guess we'll just go with C. And correct. All right, so the set will change the item at index 2 to 4. So we saw that here. But then the add of 5 at index will move everything else to the right and insert 5. So we kind of saw that here. So then the 4 got moved to the right. And then finally, the last add will be at the end of the list. So 6 will just add it to the end of the list. So for this one, what will print when the following code executes? So, oh, I haven't introduced remove. Okay, so remove, basically, it removes the element at the specified position in the list, and it shifts any subsequent elements to the left. It subtracts 1 from their indices. So think about when you were trying to remove from an array. It was kind of hard in the same way as adding to an array was hard, because you had to actually make a separate array that was one smaller, and you had to copy all the elements over and then not copy the one that you wanted to remove, and then I don't know, just do all this messy stuff. But with an array list, you can remove directly, and it'll shift all the elements from the position that you moved to the end forward.
Huh? Huh? No.
All right,
I'm on
so
the webinar. It's okay. It's about to end. It ends at 8 or. Yep.
Okay, so if we call this remove method, then it basically just shifts everything to the right, as I said, and you don't have to worry about like changing the size or anything. It does everything for you. So it basically just removes 1 from the list, kind of like how you'd remove really anything from a list. What do you think would happen if we printed out list 1 at this point? What do you think the following code would execute? It's not supposed to be a trick question. C. Okay, so all right, so if we had 1, 2, let's check. Unfortunately, that is incorrect. The 3 is at index 2, and the item at index 1 will be removed. So what is the item at index 1? Remember that when you add an item to an array list, it basically, it kind of just like stacks them up on top of each other. I guess that's not really the best analogy, because there actually is something in Java called a stack. But just think about it, that when you add an element, it just adds it to the next available position in the array. And so what would be the first element in this array list? Because you remove the 3, so 1 is 0. We're not removing the 3. When we call remove, we're passing in 1. And 1 is the element that we're trying to remove.
Oh, that makes sense. That's what. Are you trying to get rid of that element or that number?
Oh, sorry. We're trying to get rid of the element that's at index 1.
Oh.
Yeah. So yeah, it's the index, not the actual element. So we're trying to get the element at index 1. And remember that Java has zero-based indexing. So out of all these options, what do you think it would be?
Would it be A? If we get rid of 1, it should be 2, 3, right?
Yeah, D, because 1, 2, 3 is the same as 0, 1, 2. Okay. So all right, so let's try D. And that's correct. So the item at index 1 is removed and the 3 is moved to the left. So remember that since Java has zero-based indexing, we're actually looking for the second element in this array list. So since the first element would be 1, the second element would be 2, and the third element would be 3. When we want to remove element 1, then we basically just remove this 2 from the list, and this 3 would get shifted to the left, and this 1 would stay the same since it was just at the beginning of the list. So yeah, it's really important to know that when you call remove, it does all the shifting for you. It's kind of just like if you had assortment of items and you were to remove one, and then you just shift everything else to the left or to the right. Kind of just to to fill the space that that object took.
Hey, I have a question.
So it's kind of like, yeah.
So you said indexing starts at 0, right?
Yeah.
So if it starts at 0, then that means it would have new integer 1, right?
Yeah, new integer 1 would be at 0.
Okay. Oh, that makes sense because if you're trying to get rid of 1, then that means you're going to get rid of new integer 2. So that's why you have 1, 3.
Yeah.
Okay.
And Shiraz, we're just going over array lists and for each loops. I apologize for starting late. You can watch the first portion of this webinar
on YouTube
so you kind of get
after it ends.
Yeah. Okay, so for this last question, what will print when the following code executes? So we have a list of numbers, and it is an array list. And then we have a bunch of add functions, and we have a set function. So this is pretty much the same thing as this question, but just with more numbers this time. So what do you think would be the output?
Would it be A?
Let's see. 2, 3, 4, 5. Okay. It says incorrect. The set will replace the 3 at index 2. So think about it line by line, just like go through it in your head or just actually write it down line by line. And just keep track of like where each integer would be, at each step in the code.
And we're not removing anything, right? We're just printing out all the integers.
No, okay. So I kind of went over like the add and set and get functions earlier. And so basically when you add something to an array list, it's kind of like the same thing as adding to the end of an array. So like
Oh.
it'll add it to the next available spot in the array. And so what set will do is it'll set item at the index that you provided with whatever element that you pass in. And the element that you pass in would be here, and the index that you're trying to set it at would be here.
Oh.
And then when you call the add function and then you pass in the an index and an element, it'll insert it at that index. But if there's something that's already at that index, then it'll shift everything to the right. Kind of like squeezing it in there.
Oh.
So do we have an answer? Okay, so we said 3 through D. Let's go with D. See if that is right. That's correct. So add without an index adds it at the end, and just same thing as they said before. So just going over it quickly. So we added integer 1 and integer 3. So it would be cool if I could do this. So this is how it looks like at this part of the code. And then we set at index 2 and integer 4. So remember that Java has zero-based indexing. So index 2 would be here. Add 1 or add 5 at index number 1. So index number 1 is here. But since we're doing an add, we basically shift everything that's already there to the right. And then we add 6. And we're basically just adding that to the end. So then we just add 6. And that is how we get our output. All right, so nice job. I guess some common mistakes would be forgetting that when you call set, it replaces the item at the index. When you call remove at an index, it moves all the items that were to the right of that index, left one index. Forgetting that add at an index moves everything that was at the index and greater to the right one index. So I already mentioned that. Incrementing an index when looping through a list, even though you removed an item from the list. So, all right. So this is an example of where array lists. So there's a reason why we like using arrays, especially if let's say if you know like how many elements you want, and like arrays are really good because they're fast. But array lists are kind of that when you try to remove an element, there's a lot of things that go, behind the scenes on when you're trying to remove an element. But basically, if you try to remove 2 elements in a row that are like right next to each other in an array list, what it will do is that, actually, I haven't gone over for each loops yet, so I'll get to that later. So because we're running out of time, kind of have to go straight into for each loops. So let's see for each loop. Where's the for each loop? Oh, looping with a for each loop. All right. So a for each loop is basically, it's kind of just like a modified for loop in the fact that you pass in, it really only has 2 arguments. So like what you do is that you pass in a list or an array. So like in this case, you have this code fragment where you have this method called get average, and it takes in a parameter called values. That's a type integer array. And you pass in the array into this for each loop. And then you also pass in kind of like the current element in that array. So like the basic syntax for a for each loop would be for the type, and then you have just any type of variable name. So you can just say var1. Then you have colons, and then you have to pass in a list. And what will happen is that it's basically saying for each var1 in the list, do this. That makes sense? So like, go through each element in this list, and it'll do something that you specify in this code fragment. So like in this example, it's basically saying for each value, and we'll call this val, you want to increment total by the value. And so what it'll do is it'll basically just go through each element in values. About it is that you don't need to know the length of values, since what's going to happen is that it'll just go through each element itself. And so a for each loop will basically just go through each element in values, and it'll just perform this code. And so that's really convenient, because let's say you have of type integer, let's say, I don't know, scores. And you wanted to loop through every score in the scores, and you can pretty much do that. The thing is, we might not know how big scores is. We might not know how many elements are in scores. And with a for each loop, you can basically say, all right, I don't know how many elements are in scores, but I can still perform some action for each element by using a for each loop. So it literally means for each this list, do something. So does that make sense? Okay. So going back to this example, value called val in values, increment total by value, and then returns total by values.length. In this example, you actually can get the length just because they're trying to get an average. But what I think would be better is if I used it with an array list. So let's say that I had like a class. So I have a class, and I want to represent it as an array list of strings. So I have array list, string, class, new array list, string. You don't need to know about these greater than, less than signs. We'll talk about that later. But they're just generics, just to show that we want an array list of strings, and you can only put strings into this array list. And say I add, I guess I'll just add your names. So like Devon, Raz, it's a Chimaka. I'm sorry if I'm misspelling your name. Oh yeah, no, I got it. Chimaka.
She left a chat.
Oh, did she?
Yeah.
I'm sorry. And then let's finally let's add Steven.
Wow, this stuff is so cool, man. I'm excited about this test.
And so we added all of your guys' name to the class. And let's say that for each student in the class, I wanted to print out good job. Do that.
We add class dot add good job.
No, I'm trying to use a for each loop.
Oh, you're trying to use a modified for loop. When you write like for,
Okay, so for.
parentheses, uh, string
Okay.
equal good job.
Equals good job.
Yeah.
Oh, does anybody agree with this? Sorry. Oh, whoops. This is
Oh,
reason
you have
the
those two dots for that's for the each loop, right? Use that.
yeah, this is
That's a
for the
symbol.
each. Yeah. Yeah, that's a symbol for like each.
Oh, okay. Oh, I just learned something new. More data.
I mean, it's not really the symbol for each, but it's kind of like what we think of as each. It distinguishes it as a for each loop.
uh,
Something that like
Devin,
has like
Devin said, "Don't you need the data type before string?"
don't need a data type before string. But what do you mean like before string? String is the data type.
Oh, he said, "Never mind."
Okay, so if we tried to if we tried to print it out, what do you think would happen? The thing is, when we pass in this good job,
Yeah.
it's not a variable. Okay, what I'm trying to do is I'm trying to print out to the console saying good job. So like I want to print out a string that says good job.
Oh,
But the thing is, when we have remember the basic syntax for a for each loop, you have your type, then your variable name, you have the colon, and then you have your list you're trying to iterate through.
so string's the variable, right?
Huh?
String's.
String is the type. String is a type.
Oh,
So like
can the variable be like string class, then the colons?
yeah, you could do string class.
Yeah, and
I
then
mean,
like
well, actually, if you did string class, actually, I probably shouldn't make this class. Make it like class one because class is
yeah,
a keyword.
string class one,
So string class one.
and then dot list. So would like the list be like string with like the greater and less than sign?
Excuse me.
Like would the list be like with the greater than less than in like string and like inside those two symbols?
Oh, okay. No, you don't necessarily. Yeah, I kind of regret using that or using the other generics. It's just it's something that like I've been accustomed to.
Uh
These greater than and less than signs, you don't need to worry about them now. Actually, just so that I can
wow.
because you really don't need them. I mean, it's
Okay.
better if you do have them.
It's better if you have
But
them, but uh
yeah, I mean, you don't need them because I don't know. Once we get to like inheritance and like polymorphism, you'll understand why you don't need them.
uh
But just in this case, uh, I wanted to have them just because it's something that I'm accustomed to doing. Because when you learn about generics, you really want to make sure that you specify what type of list you're making.
yeah.
So, example. So we have string class one and then colon good job. Can anybody tell me why this wouldn't run?
Mm,
There's something key here that's like it's so close to the correct syntax is, but it's missing one thing.
It says no return and no expression. That's what he said.
No return and no expression. Well, it's not really the return type or the return value, because we're not really returning from main or returning from anything inside here. It's
Hey,
something that has to do with this. Yeah.
remember the line of code that you wrote, which was like basically the syntax for the for each thing? Can you type that again?
Yeah.
Because that helped out a lot.
Oh yeah.
If you
Oh,
didn't
okay.
put that up, I wasn't going to be able to say anything. Uh, so good job is not a list.
Exactly.
So on that side, it has to be a list. So
Yeah, it has to be some type of list.
so what's the name of the list? Like class one or like
Well, we only have one list here.
oh, we got to give it a
It would be
name or
class
already
one.
has a name.
Yeah, exactly. But the thing is, and so I was hesitant to say that class one wouldn't really be a good name for this variable because it's the name of the list that we have here.
Devin said, but if you are returning a good job for each student, why can't it?
Why can't it?
Yeah.
No, when I say good job, I'm trying to print out to I'm trying to just print out to the console saying good job. System.out.println, good job.
Oh, you trying to print it out without the system out print line, or
Yeah,
just show that?
System.out.println.
Oh, okay.
And so
So the
that's
way
what I
that you
meant
have it
when I
now,
say,
it's going to work.
well, I'll still need to, because this isn't a list.
Oh, we got to put the list. Good job is not a list.
Yeah,
Oh,
exactly.
I get it. You're going to system out print line good job, but it will not work because you don't have your list.
Yeah.
Okay. So how will we name the list?
Well, we already have
Will
a
we name
list.
it? So will we name it like ArrayLists class one or?
Well, we already have class one here, so if we just pass in this as the list, just to avoid shadowing, we should rename this to, let's say, student. And so what this says is
So
that for each student in class one, print out good job.
oh, that looks much simpler. Well, you said if it was like class one, you said it's going to be like a shadow technique, or what's that?
Yeah, it'd be something called shadowing. I don't. It might work. I don't know. I haven't ran this code, but just from my Java knowledge, and from what I remember, generally you don't want to do that. And
It
plus,
sounds
it doesn't really
complicated.
even make sense. Yeah, it doesn't make sense because if you were to pass like string class one for each class one, or for each class one, do class one, doesn't really make sense.
It doesn't make sense. It doesn't sound fluent. Like
Yeah.
well,
All
that's
right.
crazy.
So if we were to run this code, object cannot be converted to java.string. Okay.
How will we fix that?
In this case, we do need string.
Ah, you should have never got
And
rid of those.
well, I assume that like you could just have it, but the thing is, I have to actually cast this, um, just so that it would not scream at me. But I'll just put in the generics, just because I know that this code will work. And I wasn't sure if when I remove the strings that it would still work, and apparently it doesn't. But all right. So if we step through this code, we have an array list called class 1, and then we add all of your guys' names. All right, so when we get to this for each soup, how many times do you think that good job will be printed out?
4 times.
4 times? And why do you
Yeah,
say that?
because it's only 4 strings or 4 students.
Okay, so let's run this. So let's type good job. And we can see that student is now Shiraz. Keep going. Print out good job. And now there are no more students to print out.
I'll only print out
And
4
we
times.
exit out that loop. So yep, it printed out 4 times. And then
Nice. I was right.
so and that's the end
Wow.
of our program.
That's pretty cool.
Okay.
Yep.
So okay, so let's say that we had um two students that had the same name.
Yeah.
And no, I shouldn't do this example. All right.
Integer.
Let's say I'm gonna do this to a set of numbers instead. So like let's say just say numbers, and then want to add say 1, 64,
And that one's going to be 64, right?
and 64, yeah, and then it's gonna be 12. So just random numbers, and let's say that if I have to do this. So say integer number numbers. Let's say number, and number, remember, is the current number in the set of numbers. So like let's say if number is equal to 64, let's say class 1, or I forgot to change this.
It's no longer class because it's no longer a string. You have to change the entire thing.
Numbers. All right, so remove. Let's see. Let's say okay. Oh no, this is the example that I wanted to do. So
Also like a nested for loop. No, you also want to do that.
yeah, you could do nested for loop, but let's say that I have like index equals 0.
You're going to remove index if it equals 64, right?
Yeah, I'm gonna remove the thing at index if it equals 64.
And then after that runs, you're going to increment it by 1.
Yeah.
Okay.
So okay. So let's run this code, and hopefully this does exactly what I do. So we just add a bunch of numbers. We set an index. We say for each number, if it's equal to 64, do nothing. Equal to 64. It's not equal to 64.
Oh, no, it is.
64.
Now it's going to remove the index. It's going to be 1, right?
So it's going to remove the index, remove it from the index.
Yeah.
So it's going to increment it. Oh, and what I wanted to do, yeah, basically what happens is that this is very important. So we get it says java.util.concurrent modification exception, and what this means is that when you remove something from a list when you're doing like a for each loop, and you increment the index, then what's going to happen is that you're incrementing the index, but like you're trying to like modify an object that you are already like iterating over. So like you're going to get this exception called concurrent modification exception. When you're trying to remove from a list using a for each loop, and that's kind of like one of the downsides of using a for each loop is that it's really hard and sometimes even to remove from a for each loop without getting something like a concurrent modification exception. Because when you remove it, then instead of like going and let's say you wanted to remove 64, what it would do the index again, and basically what happens is that it's kind of like it wouldn't 64, but it'd like move right to 12, and so you kind of like leave this 64 out. Does that make sense?
Yeah.
Okay. All right. Okay, so that was really all I wanted to show you with that. We unfortunately weren't able to get through all this. Okay, I guess like one quick thing that I can do. Actually, yeah, I think I have time for that. Even though we went over time, I can just do this this one thing really quick. So you guys have gone over 2D arrays, right? Are on 2D arrays. All right. So
Yep.
does everybody feel like semi comfortable with 2D arrays?
I feel kind of comfortable. Like, yeah.
Okay. So one thing that they wanted me to go over with you is how you can use for each loops to loop through 2D arrays or arrays within arrays. So let's say that you had a 2D array of ints called, I don't know, let's call this matrix. Or actually, let's just call this like checkerboard. I don't know. Does anybody know like how many rows and columns are on a checkerboard off the top of their head?
Is it? I don't know. Is it like 8 rows and 8 columns for a checkerboard?
I don't know. Let's just say that it is. Okay. So we have a 2D array of that's 8 by 8, so it has 8 rows and 8 columns. Yeah. So let's say what we can do is that what you usually do is you'd use like a for loop, and you'd like say like index 0, and then index is less than checkerboard.length, and then you do and you make like a second nested loop where you like have like index 2 is equal to 0, index 2 less than checkerboard at index length, and then you like increment all that, all that jazz. But you can clean it up and make it look much more elegant if you use a for each loop. And so with for each loop, remember that we have a type then we have the colon, and then we have the list. And so if we wanted to iterate through a 2D array, basically what we could do is we could have the type through each array in, I guess you could say, each array for each row in the array. So like, since a 2D array is just an array of arrays, what we can do is we can iterate through each array in the 2D array. Say like for each row, actually this would probably be column. Actually no, this would be row. So row in checkerboard. And so basically what this outer loop would be doing is it would be saying for each row in the checkerboard, and let's say, I guess, would this be space? What this would be saying would be for each space in row. But remember that row is an array, and that row, we're doing this for each row in checkerboard. So what would be happening, and I don't know, for the code, let's just say, I don't know, checkmate. Something like that. Code. And you can see that it creates an array of arrays. It creates a row array with eight spaces, and then each will point to another array that is also of size 8. So you can see that here. And when I say for each int array row in checkerboard, what this basically will be saying is it's going to point to one of these. So you can see how these are the same. So like this is the same as this. It's going to be iterating through each of these separate arrays in checkerboard. And checkerboard is this entire thing. It's going to be saying, so for each one of these, iterate at a space in the row. And so space would be 0. I didn't initialize anything. I'm pretty sure it would just be 0 for all of them. And you just have this code. It exceeded max visualizer time limit. But anyway, if this was, to go on forever, what essentially would happen would be you would print out checkmate 64 times, because there are 64 in the checkerboard 2D array. So you'd say for each row, you want to print out all the spaces, and then you do that for all the rows. And since there are 8 rows and 8 columns, you do it 8 times 8 times, so 64 times. So I just wanted to show you this example because it kind of just shows, it kind of culminates everything that we've been doing. So it shows like an example of 2D arrays and how you can use for each loops to iterate through them. So you can kind of like clean up your code, make it, I guess, a little bit more readable. Are there any questions about iterating through 2D arrays with for each loops?
No.
Does that sort of make sense?
Yes.
Okay, so are there any like general questions about ArrayLists or for each loops before I have to go?
No.
No? And is that you guys definitely do the practice problems in the ebook. I only did like 1 page, but you guys could probably do like a lot more on your own. The most practice with working with these. And as I said, the only three operations that you'll need to know are like adding, setting, and removing. Oh, and getting. And those are like the only things that you're going to need to know. So just make sure that you study that. But other than that, array lists and for each loops are, for the most part, not too tricky. They won't throw you like any curveballs with them. But yeah. Any questions? Oh
Hey,
wait, when is it
Steven.
appropriate to use either concept?
Huh?
Huh?
No, I was going to tell you. Devin asked a question.
Okay, when is it appropriate to use either concept? Are you talking about like an array list or an array? Okay, so I would say they use an array. I mean, if they ask you to use an array list, then definitely use an array list. But if they don't ask you to use like either one, I'd use an array if you have like a fixed set of values. So like you know what the size of the array is going to be. And I'd use an array list if you don't know what the size is going to be. But like, let's say you don't have to remove anything from the list, then I would definitely use an array list because for one thing, you don't have to go through the trouble of like copying the array and like shifting all the elements over, and you can pretty much just have the array list do it for you. But other than that, I'd probably use an array. It's basically just context. All right. Thank you. And if there are no further questions, then hope you guys have a good week. Thank you for coming to this webinar, and I'll in-person meeting on Saturday from 3 to 6, I believe.
Yep, it's 3 to 6.
6?
Yep.
All right. All right.
It's
Bye,
on
guys.
YouTube, right? The video?
Yeah, we're going to have a Google Hangout. Yeah. We're going to try to host it online as well.
Okay. No, I'm talking about this webinar. It's on YouTube, right?
Oh, this webinar? Yeah, this webinar will be on YouTube.
Because I read on the email it's going to be a Google Hangout, and then you can physically like come to the department.
Wait. Shiraz?
Yeah.
Oh wait, did you say something?
Yeah, I said in the email it said you guys are going to create like a Google Hangout for the people that don't come, and then it's a physical like everybody meet up at the department.
Yeah.
Yep. But
yeah, that's exactly what happened. Yeah.
Yep. Well, I'll see you Saturday and have a good night.
All right. See you, man.
Yep. See you, Steven.
All right.
Yep.
All right. See you next time. Thanks for coming.
We good?